demonstrating the expansion of metals is generally not an easy thing to do. And I've developed here an apparatus that can be used to show that when a wire is heated, it actually expands. I have a wooden structure that I've made. It's about 1 meter long. The length itself is not critical, with 2 upright supports and a wire then that is suspended from one end and runs over a pulley on the other end. The wire that you use can be any kind of flexible wire, because it has to be able to rotate easily over the pulley. Guitar wire is good. So if you have yourself or a colleague that is replacing the wires on a guitar, you can probably save one of those wires and use it for this apparatus. If the wire happens to break during one of your tests, you can actually just join it together again by twisting the wires together so that you don't have to replace the whole wire. At the bottom of the one end, you can see then the screws that hold the vertical in place. The stand has a screw eye to which the wire is attached. You could also just drill a hole through the end here and wrap the wire around and tie it. It needs to be secure. The other end has a pulley on it over which the other end of the wire will run. And as the wire expands when it's heated, it actually causes the pulley then to turn. And that then is indicated by means of a dial which has been glued onto the pulley, and you can see that it rotates, and we can then see movement in the dial as the wire itself expands when heated or contracts when it's cooled. We need to keep the wire taut as well, and to do that we hang a weight on the end. What I have here is a 2-liter pop bottle, and I've put a hook on the end using a piece of wire, just a heavy piece of copper wire, it could be any kind of wire, so that I can hang that through the end of the wire where I've made a loop. And I hang that over the edge of a table so that the wire itself will be taut. So here we have the apparatus set up. My wire is here, over the pulley, and hanging on here is a 2-kilogram mass, the pop bottle filled with water. Now I'll use my torch to heat the wire along the length. The advantage of using a torch is that the flame shoots out a long distance, and so I can heat a good section of the wire. If I use an alcohol burner, I'm only heating a very short section, which takes a long time to heat the wire up. And even if I move it back and forth, the wire cools too quickly to see any noticeable change. You could use half a dozen alcohol burners under here and have students hold them. The torch seems to work well. I'll now focus on the dial, and we can then see what happens when the wire itself is heated. We'll now apply heat to the wire. What you just observed was the wire being heated too much and actually breaking. So let me try to heat it again without quite as much heat. I'm moving the flame back and forth over the wire, making sure I don't heat it too much. And you can see that when I heat it, the wire stretches as indicated by the movement of the needle. An important application for the expansion of metals is in electrical transmission lines. If you look closely at them, you'll notice that they are never really tight. And that's done for a purpose. In the summertime, when the wires get hot, also when there's a high electrical load on the wires, they do tend to heat up. They will tend to stretch and hang lower. If the wires are cold, the wires tend to contract, and you'll notice that they're hanging a little bit higher. And so the design of the electrical transmission lines has to incorporate and allow for the expansion of the wires with changes in temperature.